Hi, I am Amey Abhyankar from FinQuest Institute. In this video, we'll understand an important relationship in the derivatives market that's called as the put call parity. This is the equation for a put call parity. So C is the price of a call option, P is the price for a put option, K is the strike price for both of these options. Both the call and put option have a time to maturity of capital T, and S is the underlying stock price. The left hand side of this equation is what we call as a fiduciary call. This is a combination of the call option plus a discounted value of a zero coupon bond with a face value of K. And we know that K happens to be the strike price of these two options as well. The right hand side of this equation is what we call as a protective put. So that is a combination of the put option plus the underlying stock price. Now we have put a equivalence sign in between. That means these two portfolios, let's call them as A and B, they are equivalent to each other. So to understand why this equality exists, let's try to do a simple analysis. So we'll take two scenarios. So first is stock price at maturity capital T being greater than the strike price K, and second is the stock price at maturity less than the strike price K. We'll analyze both the portfolios and we'll see how they are equivalent to each other. So let's focus on portfolio A, that is the fiduciary call. So here we are going to apply the payoff conditions for call and put options. So to do a quick recap of the payoff for a call and put. So for a call option, we have a payoff condition which is given as max of ST minus K or 0, with ST being the underlying stock price at maturity, K being the strike price of the option. And for a put option, this is given as max of K minus ST or 0. So we'll be applying these two conditions for analyzing the scenarios. So focusing on the call option, by applying the payoff condition, we see for a scenario where ST is greater than K, the call option payoff is ST minus K, and a zero coupon bond is going to be maturing at face value K. Next, the scenario where stock price at maturity is less than the strike price, the call option will not yield a payoff, it will be 0, and a zero coupon bond will anyways mature at K. So here we see that the ZCB will remain unimpacted in either of the scenarios, because with the passage of time, the zero coupon bond is going to mature at its face value, which is capital K. So on a net basis for portfolio A, in the scenario where stock price is greater than the strike price at maturity, we have the value which is given as ST. I simply sum these two together. And where my stock price at maturity is less than the strike price, I get a value of K by adding these two terms, 0 and K. Now let's focus on protective put, which is portfolio B. So applying the payoff condition for a put option, which we have just written. So in the scenario where the stock price at maturity is greater than K, the put is not going to yield any payoff. So the value will be 0. The stock price at maturity is going to be ST. Now let's take the scenario where stock price at maturity is less than the strike price. So now the put is going to yield a positive payoff because the stock has fallen below the strike price. Now applying the payoff condition, I get K minus ST. Stock price will mature at ST anyway. So here we see that the stock price is going to be ST in both the scenarios. It will be unimpacted whether the stock price is greater than or less than strike. Now, just like we did for portfolio A, if I add up the two terms, so 0 plus ST in the first scenario gives me a net value of ST in the scenario where stock price at maturity is greater than K. And in the second scenario, adding K minus ST plus ST, I again get a value of K. So on a net basis, we see that portfolio A and portfolio B are exactly equal to each other. That's why we say that there is an equivalence which exists in this put call parity equation. So that's why we say a fiduciary call is equal to protective put. This leads us to a relation which we call as a no arbitrage condition. That means if there is a violation of this equality, it will generate arbitrage opportunities. Now, how to capitalize on these arbitrage opportunities, we'll see in our next video.